Good morning to all. Today I am going to discuss a very important topic, that is Compton Effect. This is a very important regarding the understanding the particle nature of the radiation. Let us start the Compton Effect. So what is Compton Effect? When a high energy electromagnetic radiation like X-ray, gamma ray, etc., that is having energy equal to or more than the 0.51 MeV interacts with the free electron of matter, that is target material. In such incident, radiation gets scattered by the electrons. Due to the non-elastic scattering, the scattered radiation has higher wavelength than the incident wavelength of electromagnetic radiation. Let the wavelength of incident radiation is lambda and the wavelength of scattered radiation is lambda dash. So the difference between lambda dash and lambda is called the Compton shift. During the experiment, we measure the value of delta lambda, and that delta lambda depends upon the number of points. First, the Compton shift is independent of the nature of target material. Second, Compton shift delta lambda is dependent on the angle of scattering. To understand these two observations, Compton himself tried to explain these experimental facts. Let us try to understand the explanation of the Compton effect given by the Compton. Now you look at this diagram, what is exactly happening there? A incident electromagnetic radiation that is having wavelength lambda, this one, this is incident electromagnetic radiation having wavelength lambda and having energy E is equal to h nu. Nu can be written as C by lambda, so that's why hc upon lambda. This is the free electron which is having the energy, total energy E is equal to m naught c square. While in the process of scattering, due to this electron, the some part of the energy being scattered which is having lower energy than the incident one. So E is greater than E dash. At in a particular direction theta, that is called angle of scattering. So the energy of scattering radiation is E dash, that is h nu dash, and where hc upon lambda dash. Whereas the sum energy being lost there is given to this electron which recoiled in a particular direction, that is phi. This is called direction of recoil, with the energy E and momentum P. E. Now, how do we explain this? The cause of Compton effect. First, a high energy electromagnetic radiation interacts with the free electron of the target material. Second, a non-elastic scattering is taking place in which energy and momentum are being conserved. Third, scattering is taking place between the photon of the high energy electromagnetic radiation and the free electron of the target material. On these fundamental logic, we try to explain the Compton effect. Note, the Compton effect cannot be explained by the wave nature of the electromagnetic radiation. To understand this, let us consider the electromagnetic radiation has the two component, electric field and magnetic field, which are oscillating. Let the incident electromagnetic radiation has the electric field oscillation with the omega angular frequency, which interacts with this free electron. It's induce a force on this body electron, because electric field induce a force whenever the positive loop of the electric field give a force in positive directions, and the negative loop of the electric field give you a simultaneously you have the alternative oscillating force acting on the electron with the angular frequency omega. Because a charged body is oscillating, so it produces electromagnetic radiation, and that electromagnetic radiation is also having a similar frequency omega. Therefore, the scattered and incident radiation are having the same frequency, angular frequency, so having same wavelength. Therefore, the delta difference between the both scattered and incident is zero. So the Compton effect cannot be explained by the wave nature of electromagnetic radiation. The oscillating electromagnetic radiation interacts with the electron. It implies oscillating force on the electron with the angular frequency omega. Due to the oscillating electron under the such oscillating force generates a electromagnetic radiation. This results electromagnetic radiation has the same angular frequency omega. So we do not have the difference between the incident and the electromagnetic radiation. Therefore, the wave nature is unable to explain the Compton effect. So how do we explain? The Compton effect can be explained on the basis of the particle nature of the electromagnetic radiation. As the wave nature of electromagnetic radiation is not able to explain the Compton effect, we would consider its particle nature of the electromagnetic radiation. Now the assumptions are there. Electromagnetic radiation is made of the high energy particles, that is photon, whose relative mass is m and rest mass is 0. Energy is E is equal to h nu, which can be also written hc upon lambda, and the momentum is p, that is h by lambda, the de Broglie, according to the de Broglie wavelength. If the such photon get scattered by the free electron, you see this figure and try to understand the what exactly happening there. This diagram is very important. This is the incident radiation having momentum p, energy E is equal to h nu equals to hc upon lambda. This electron is free, that is E, and this is the scattered radiation having the momentum p dash and the energy E dash at the angle theta, that is angle of scattering. The electron get recoiled in the direction of phi, having the energy EE and PE, where theta is angle of scattering and phi is direction of recoil electron.